These are the frequently asked questions for pre-calculus for the second day of section 3.2, and I have problems 20, 21, 22, 28, and 32 on the list. So we'll start with number 20, and number 20 says in exercises 19 and 20, determine a formula for the exponential function. That's a huge giveaway to what we're supposed to do here, whose values are given in table 3.11. And for 20, we're supposed to do this for g of x. So there's two things I'm looking for. Again, I'm thinking about that y equals a times b to the x, that simple model that we have for exponential functions. And a is always the initial value, and that's where we have an x of 0. So for g, that's going to be a negative 5.8. And then the next thing that I need is b. And b is the base that we have. And what that tells us is that's the number that they are multiplying by each time. So if I want to find the number that's being multiplied by each time, I'm going to have to do division. So it doesn't matter if I take negative 7.25 and divide it by negative 9.0625, or I take negative 5.8 and divide it by negative 7.25, or negative 4.64 and divide it by negative 5.8. As long as I divide one of those, I will see that they come out to 0.8. Now the one that's going to come out a little bit different, it appears they did some rounding for the negative 3.7123 divided by negative 4.64. It's not a perfect 0.8, but it's pretty close. So that is our b value because that's what they are multiplying by each time to get the next y value that we see there. And then of course we just put an x up there, but in this case we probably would change this into the function notation because they said this was g of x, and then it would all be perfect, you know. So it all starts with that basic y equals a times b to the x, and you just use that to figure out what are the values for a and b that I have here. Same type of thinking in 21 and 22. So with 21 and 22, what I noticed in 21 is that my a value is definitely going to be 4 because that's my 0, 4 right there. And then I see it went from 0, 4 to 5, 8.05, and I need my b value. So my b value comes from the fact that what we had initially had to be multiplied by our base 5 times. Well, what we had initially was a 4, and then there was some number when they were constantly increasing that power by 1 that they multiplied by 5 times in order to get the 8.05. So we would divide both sides by 4. And then we would take the 5th root. So 5th root of x to the 5th is of course just going to give us x. And then we need the 5th root of 8.05 divided by 4. Now since I didn't know if that was the problem, that maybe you forgot how to punch in something like 5th root, I thought I'd go ahead and load up the calculator here and tell you. You go back to the main screen and you punch in a 5. That's to tell the calculator 5th root. Then you hit math and we pick our generic root button, which is down here. It's number 5. That's little x that you see there is the number that you just punched in on the main screen. So that tells it you want the 5th root. And we want the 5th root of 8.05 divided by 4. And there it is. So we would go with approximately 1.150 with rounding for our b value. So we have a, we have b, and now it just comes down to giving it a name. I'm just going to call this one f of x. So f of x equals our initial value of 4 times 1.150 to the x power. And now we have that exponential function model that we needed. Same thing, same principle, I should say, in number 22. So for number 22, I noticed that my a value is going to be 3 because it's 0, 3. That's the initial value. But this time, to go from 0, 3 to 4, 1.49. From 0 to 4 means they multiplied by the same number 4 times in order for this to happen. So it was a 3, and then they took that b value for the base and they multiplied that 4 times in order to get 1.49. And then we would divide both sides by 3. So x to the 4th equals 1.49 divided by 3. And then we'd take 4th root of both sides in order to get our numbers. And our base value here, we're just going to keep that positive since this is all above the x-axis here. So x will equal the 4th root of 1.49 divided by 3. And again, I'll just demonstrate one more time. 4th root, we would punch in 4, math, and then go down to number 5, which is our generic root, and you can see that'll give us our 4th root there. And 1.49 divided by 3. And there it is, approximately 0.839 to 3 decimal places. And that's our b value. So we start at the beginning and say, all right, I'm going to name this one g of x. The initial value that we had was a 3. And we just found our base, 0.839, and we're going to raise that to the x power. So it's really using that thought process of y equals a times b to the x. And then how do you find a? It's always the initial value. It is your 0, well, that's actually your y-intercept. You put a 0 in for x is what I was going to say. And it's your y-intercept. And then you have to notice, well, how much multiplication took place, because this is going from x equals 0 to x equals 5. They had to multiply by that base 5 times. But this one goes from x equals 0 to x equals 4. So they were multiplying by that same base 4 times. And that, of course, determines your root that you need to take. Number 28, this is a logistical function, and we actually just went through all of this in class today, so you probably don't need me anymore, but I'm going to go through it anyway. And we think about our logistical model, which has our upper limit on the top, and that pretty obviously in number 28 is 60. We see that they labeled that asymptote really nice for us there. And then we'd have 1 plus a times b to the x. So what we have to do here is use the information that we have, and here's the first important piece of information, and that is if you put a 0 in, you're going to get 15. So 15 is what we will get if, and I want to make that readable there, we've got a 60 over 1 plus some value of a, and then b is to the x power, which in this case is 0. So we will have 15 equals 60 over 1 plus a, because anything to the 0 power is 1. And as you saw in class, easiest thing to do is to pop a 1 underneath there and do a little cross multiplying, keep it all logical, and divide both sides by 15 and subtract. And we get an a value of 3. So now we have this. We have our f of x equals 60 over 1 plus, and what we just found was the 3. So here's the last bit we need. We need to figure out that base. And that comes from the last piece of information that we have here, which is if we put an 8 in for x, we should get 30. So 30 over here means that this was b to the 8th. And again, we would go ahead and slap a 1 underneath here and cross multiply. So 30 times 1 plus 3b to the 8th equals 60. Divide both sides by 30. Move the 1 over by subtracting. Divide by 3. And then we need the 8th root of both sides. Now, at this point, there are 2 things we're looking for. First of all, if this is just a free response problem on the AP exam, we certainly could just punch this in and get the 8th root of 1/3. And let's see, the 8th root of 1/3 comes out to be approximately 0.872. But for a perfect answer, we would keep working with this and say, all right, the eighth root of 1/3 is the same thing as 1/3 to the 1/8 power. And then 1/3 is the same thing as 3 to the -1 raised to the 1/8. So that is really power to a power is multiply 3 to the -1/8. So now let's go back and see all the information we had before. We had f of x equals 60 over 1 plus 3, and now we found our base, which is our 3 to the -1/8, and we would raise that to the x power. So what we're seeing here now is what might happen as a multiple choice answer. So what we're going to do is we're going to simplify this. This would be 60 over 1 plus 3. Well, 3 to the -1/8 raised to the x power, we would multiply when you raise a power to a power, and that would be 3 to the -x over 8. And then you should notice we have multiplication of similar bases. And when you multiply similar bases, you add the exponents. So f of x would equal 60 over 1 plus 3 to the -x over 8 plus 1, because we would add those together. So in multiple choice form, you might see an exact answer like this. But certainly for the free response portion, we could just go ahead and use a base here of 0.872. And I know that's what your book did. It just went right ahead to that. But again, you have to be able to work between the two systems, free response and the multiple choice. So what you're probably going to see in the book would be f of x equals 60 over 1 plus 3 times 0.872 to the x. And that, of course, was a rounded answer, whereas this is going to be a perfect answer. Then, number 32, back to exponential growth again. This says the population of River City in the year 1910 was 4,200. So, thinking about that exponential growth, assume the population increased at a rate of 2.25% per year. So, it started at 4,200, and then we need our little 1 plus r. But our interest rate, remember, we have to move that decimal 2 places over. Pardon me. And so when we add 1 to that, we're going to get 1.0225. Too many zeros in there. 1.0225. So there's our model. And for A, it says to estimate the population. At this point, I might want to fancy this up a little bit and maybe make it P of X with the function notation. And if we want to know about 1930, well, 1930 minus 1910 is going to give us 20 years. So what we're really trying to find is P of 20. And then for 1945, if we take 1945 and we subtract 1910, we're going to get 35. So we would also want P of 35. And so with these two, all we're going to do is punch this in on the main screen and round it to the nearest person. So on the main screen of the calculator, we would have 4,200 times, and then we have 1.0225, and the first time it was 20 years. So that's going to be approximately 6,554 people. And then if I hit second enter, I can just change my power and make that 35 for the other part of the problem, which was 45 years. And that's approximately 9,151 people. So that would be how we would answer. So P of 20, 6554.139 is approximately 6,554 people. P of 35, 9150.933, so approximately 9,151 people. Then part B. Part B says, predict when the population reached 20,000. Well, we know that what we're really saying is that we want to know when is 20,000 equal to 4,200 times 1.0225 to the x. And since the book is doing this with the graphing calculator at this point, that is what I'm going to do. So if we go back to the calculator and go into y equals, you'll see that I already have that punched in. And then we need our window, and I was guessing that it would happen within 100 years here. That seemed like a good estimate. And because we were looking for 20,000, I had my y max at 30,000. And hit graph, and there it is. We do see an intersection, so second trace, number 5, bing, bang, boom. You enter 3 times, and good old Blinky helps us out and says 70.139, so we're going to round up. So 70.140 years later, and since this is years, we're just going to go ahead and go with 70 and say, all right, this started in 1910. If we add 70 years, it should be sometime in 1980 that that's going to happen. That looks too much like a negative there. Oh, for goodness sake. Let me write this clearly. 1910 plus 70, 1980. So that's when we would expect that to happen.